All right, guys, just two more quick examples, and then that'll be it for the morning portion of the lessons. Okay, as per usual, uh, when we find the derivative, we find the equation of the tangent for all points around a curve or a function. And if we were interested in the specific slope value at a specific x value, we could find it. And that's what we're going to do here, right? So we're just going to apply our quotient rule as per usual. We've seen this tens of times now, right? We're going to find the slope of this tangent line, or slope of the tangent line to the curve of this function, right? So we're going to apply, I see a quotient, right? I see a function divided by a function, so I know I'm applying quotient rule. And then I can find exactly what the slope is when x equals 3 on this curve. Okay, so first things first, we're going to find dy by dx. Okay, and we know we have to derive the top. So it's 3x squared multiplied by the bottom, x squared minus 6. And then we have to subtract off. We're going to derive the bottom, be 2x. And then multiplied by the original top, x cubed. And all of that needs to be divided by x squared minus 6 squared. Okay, so let's do some cleanup. And so we'll expand the top. We're going to get 3x to the power of 4 minus 18x squared. And then we're going to subtract off 2x 4. All needs to be divided by x squared minus 6 squared. Okay. And then we're going to find that dy by dx will equal x to the 4 minus 18x squared divided by x squared minus 6. So here is that squared. There's your derivative. Okay. If we were interested in specifically x equals 3, we would take that value and plug it into there to find what the slope value is, right? So at x equals 3, the slope of the tangent would be equal to 3 to the power of 4 minus 18 to the 3 squared divided by 9. We'll say 3 minus 6. 3 squared minus 6 squared would be 9 minus 6. Oh, back here. We'll just fill all this out now. We get 81 minus 18 times 9 over 9. Okay, so the slope there is going to be negative 9 when x equals 3, right? Okay, nothing too crazy. Okay, these are nicer questions than what would be on your first summative, right? Where we had to find the slope of the tangent using first principles and then do all of this work. But this is all the same stuff that we've been doing, right? It's just a much faster way. Okay. So second point here is find the points where the tangent line to the curve, this f of x function, is horizontal. Okay. So we're going to have a look at same thing as per usual, right? I have to derive this function, right, in order to find, the slope of the tangent. And then from there, we want to just know where the slope of that tangent is horizontal, right? Which we can figure out. Okay, so first things first, let's derive it. Okay, we know, the slope of the tangent is the derivative of f of x. Okay, there's nothing new there. So let's find f of x. Okay, f prime of x, sorry. So let's derive f prime of x is going to equal 2x multiplied by x squared plus 1. And we're going to subtract off 2x times x squared minus 1. and all of that needs to be divided by x squared plus 1 squared. Okay, clean it up. Is going to be 2x cubed plus 2x minus 2x cubed minus 2x, okay? All divided by, you guys be careful with the negative and what's going on here, okay? I always, do the work with the brackets first and leave the minus sign so that you can easily see what's going on. Okay, divided by x squared plus 1 squared. Okay, and do the final cleanup in the numerator. Is going to be, well, we see 2x cubed with the 2x cubed, 2x with plus, oops, I'm not going to cancel, sorry. We're going to add, right, because the negative and the negative make a positive. So we're going to see 4x over x squared plus 1 squared. Okay, that is the slope of the tangent, right? Now, we want to find out where, at what points in time, right? So basically find x if, the slope of the tangent, remember, if we're talking about horizontal, the slope here, m has to equal 0, right? So we want to find x if m, the slope of the tangent, or f prime of x, is equal to 0. Okay, so we just set this function equal to 0. We say 0 equals 4x over x squared plus 1 squared. Right? And we find out that we're going to get 4x is equal to 0, x is equal to 0. So there you go. So when x equals 0, right, we get the slope is equal to 0. Okay. Now if we were to actually, now we know, because I think it actually asks for find the point or points, right? So I need a point value. I can't just have an x value. So I need to take this x value and plug it into the original f of x function, right? To find the actual value. So I need to find what f of 0 is. So it's 0 squared minus 1 over 0 squared plus 1. Well, I get negative 1 over 1, 1. Okay, so we know oops, negative 1, sorry. Okay, that's it, guys. Okay, we can find where something is horizontal, right? And that's just, if I told you that find where the tangent line is, I don't know, -5, right? You could do the exact same work and solve for the x values that would be true. Okay, so that's that. All right. This afternoon, we're just going to look at another derivative law, and then by the end of the week, we'll be kicking it into gear to actually apply derivatives, okay, and rates of change and things like that. Okay, so that's that. You should have a bunch of questions to do with quotient law, and this afternoon we'll look at what we call chain rule. Okay.